Hey guys, if you're watching this video, I guess you're interested in GPU repair, yeah? That's what I'm here, hopefully on this video, to help you to learn. So I'm going to try to put together a complete guide to GPU repair, which I've not seen. I've looked at quite a few videos, I've not seen this done before, so let's see how it goes. My name's Richard. If you've not been on the channel before, welcome to Learn Electronics Repair. I hope you enjoy this video, and I don't really ask this very rarely, but if you like this, if it helps you, please click subscribe if you would. Yeah, simply click like and put your comments below. Let's see what you think about it. Okay, so this video is specifically for graphics cards that do not detect. Yeah, so you put the GPU in the PC and it doesn't detect. The video will also help you to diagnose any graphics card that you do not know the condition of. So if you found a graphics card at a car boot sale, in a skip, if you bought it on eBay as spares or repair, and you have a graphics card that you do not know the condition of, this video will help you to diagnose that. Yeah, if you have a graphics card that's of your own that's suddenly failed, again, it will help you. So if you follow this through to the end, if you can't repair the card, you should at least know exactly what's wrong with it. Okay, so let's start from the very beginning. If you want to repair graphics cards, you're going to need a little bit of equipment. So let's have a quick look at what you're going to need, what's essential to have, and what would be nice to have. The first thing you're going to need is a multimeter, and this is essential. Yeah, I have two that I use commonly, which are these, the Fluke and the Aneng. Yeah, I mainly use the Fluke just because I've had it for a long time and it's my favourite meter, but this one is a little bit more sensitive at measuring resistances. This goes to 1 decimal place, like a 1/10 of an ohm, and this goes to a 100th of an ohm, and sometimes that's useful. Yeah, so these are the ones I use. If you don't have a multimeter, I can recommend this. It's a nice little tool. It's about €20 or something. It's not expensive. Yeah, and it's a good meter, ideal for this sort of work. Yeah, the Fluke's very nice if you've got €100 to spare for a used one, maybe. Yeah. The one thing I will mention, regardless of what type of multimeter you use, is the meter probes. So you want meter probes with very sharp ends on them. Yeah, the meter probes that come with a multimeter are always rubbish. Yeah, almost always. You want something like these. These are getting quite worn now. This is another type that I use. Again, it's a very sharp needle point. So whatever meter you get, make sure you get yourself some good probes like these. It'll make your life much easier. The meter is actually this Aneng 8008 is the one I have. I've had this for about 5 years. Something like that. There's now I've noticed, I just had a quick look at the price, and there was an AN8009 that appears to be just an updated version of this. They were available on AliExpress, and we had them on offer at around €25. But as I say, it's not totally essential, but you know, at that sort of price, it's not overly expensive. Just get yourself a decent meter. If you're going to buy one, you'll probably only buy one, so you know, just go for something that's good. Yeah. So apart from the meter, the next thing that you're going to require is a bench power supply, and really we can also class this basically as essential really for this sort of work. There are quite a lot of variable bench power supplies, and again, it's not particularly essential the type you have. I've had this one since 2016, and it cost me about €50 or something, 40, 50, something in that region. This one's a 30 volt 5 amp. Yeah, so on here you can set it to deliver whatever voltage you want, and you can also set it to deliver a certain current. So if you just want to send 2 amps into maximum to a voltage rail, you can set it to do that. Yeah, this is just a single voltage supply, and this is all you really need for graphics card repair, and for that matter motherboard repair as well. If I was buying one now, to be quite honest, I'd buy the 10 amp version because there isn't a great deal of difference in price. But a 5 amp one so far I've found very rare occasions that I need anything more than that, and those occasions were not really actually on graphics card repair. So put that on your list of essentials. If you're going to do this sort of work, you're going to need something like this. Yeah. In order of usefulness, after the multimeter and the bench power supply, this is the next thing I would say that you should buy. Yeah, this is an EEPROM programmer. This one actually is a TL866. It says it's an A, but it's actually a CS with the connection for programming EEPROMs in circuit. Yeah, this itself is not ideal for programming graphics cards BIOSes, because GPU BIOSes, all the recent ones, are actually 1.8 volt, and this doesn't actually program 1.8 volt chips. Yeah, there's an adapter you can get for this, which is only in the region of about €2 actually, that will adapt it, and then you can program them with this machine. A lot of people also like a programmer called the CH341. It's another EEPROM programmer that a lot of people recommend. You can have a look around on forums, but it's very useful to have an EEPROM programmer. Occasionally you'll find graphics cards that somebody has modified, yeah, or they've been flashing the BIOS and the power's gone off and basically it's bricked. Yeah, it won't come back unless you reprogram the BIOS. You can only do it with an external programmer. So that should be the third thing on your list. Fourth thing on your list is an oscilloscope. You don't need an oscilloscope for most graphics card repair, but there are cases where it becomes very useful. Yeah, it doesn't have to be expensive. I've actually got 3 different oscilloscopes here. I mainly use my analog one, but I have a digital one. But something like this, the Handtech, you can see the price, €66, and if you're outside the EU, or I'm in the Canary Islands, so I'm in the EU but outside of the customs union, that would actually cost me 55. Yeah, 20% off, 21% off. So if you have a shopping list and a budget, and you don't have an oscilloscope, something like this is very handy for motherboard and graphics cards repair. So we can put that down as number 4 on your list. So that's all the test equipment you actually need, and the oscilloscope isn't essential. There's just certain cases where you may find you need that. Yeah, even the same with EEPROM programming. You can do a lot just with the multimeter. But if you're serious about graphics card repair, then you should be looking at getting that sort of equipment. A couple other things that I found are quite nice to have. This is an ESR meter. This is intended for measuring capacitors, electrolytic capacitors, yeah, which is basically to do with power supply and amplifier repair. But I've found that this is a very handy tool for finding short circuits, particularly in graphics cards and motherboards. So it's one of these nice things. You don't really see anybody else talking about using one of these. I made a whole video on it, but you might see me using that, and I'll tell you when this can be useful. And the last thing that can be very useful is a low ohms multimeter, or sorry, a low ohms meter, something that can measure thousandth or millionth of an ohm, so a milliohm or micro ohm meter. They're not easy to get your hands on. There are some I've seen that are quite cheap, which I want to get one and try it. That again could be useful for short circuit tracing, but it's not essential. Okay, so that's really all the test equipment covered, and there's a couple of things which we're now going to discuss. Yeah, if you're lucky enough to have 20/20 vision, yeah, very good eyesight, then you may be able to get away in a lot of cases without any sort of magnification when working on these sort of items. Personally, I find that for me is not the case, so I use magnification. I mainly use 2 things. One is the bench magnifier, yeah, so this is 5 diopter bench magnifier. 5 diopters is not 5 times magnification, by the way. Diopter is diopters divided by, well, sorry, 1 plus diopter divided by 4. So diopter is 5 divided by 4 is 1.25 plus 1. This is a 2.25 magnifier. And I use this quite a bit, especially on cases where I can't get the microscope close to the graphics card for any reason. I use it mainly for other repair work, but that's a fairly cheap way of getting some magnification. The other thing I used a lot was this. This is a jeweler's loop, yeah. This gives me 10 times magnification, so you just get close to your iron loop through. This is handy, again, not so much on graphics cards, but you could use it on that. I find this on items where they're bulky or at a certain angle I can't get it under a microscope. Which brings us to the third method, and that's my microscope. This is trinocular, it has a camera on because I use it for the YouTube, but a binocular optical microscope is very good tool. This will allow you to do micro soldering easily. Yeah, it makes the impossible easy. So consider some sort of magnification. If this is out of your price range, a USB microscope, just make sure it's one that gives you enough range to work underneath. Personally, I can't solder with a USB microscope because you lose your depth of your depth perception. Yeah, I can't solder under them. Some people swear by them. Yeah. All I'd suggest first, if you're going to try a USB microscope, is put an eye patch on and try and solder one-eyed for half an hour and then see what you think. Yeah, I would personally buy a cheap binocular optical microscope rather than buying an expensive USB microscope. Yeah, but if you're on a budget, get yourself a USB microscope and learn to live with it. Yeah. Obviously, once you've diagnosed the problem with your graphics card, or for that matter sometimes so that you can diagnose the problem with the graphics card, you're going to have to remove or replace components, and for that you need soldering equipment and desoldering equipment. The first one obviously is a soldering iron. This is my KSGR T12 soldering station. If you're buying a soldering iron, in fact if you've got an old soldering iron, get yourself one of these. They're not expensive, about £40, something like that, 40-50 euros, and these soldering irons are 75 watt, and they come with all these different types of tips you can get separately, yeah, not included. And these have the heating element actually built into the tip, so they're much more efficient at getting heat into the actual job. Yeah, graphics cards are phenomenally difficult to work on. If you don't get enough heat in, you cannot solder or unsolder parts. What you'll find you can do is wreck PCBs quite easily. Yeah, so in my honest opinion, a T12 should be your minimum. Yeah, but I say your minimum is actually a damn good soldering iron for this sort of work. I mean, if you want to spend lots of money, you know, on a Pace or JBC, is it JCB, whatever they are, JBC, fine. But if you're on a reasonable budget, one of these. Yeah, if you've got an old soldering iron that isn't T12, a soldering station that isn't T12, you're not going to get far with this sort of work. That's my honest opinion. Okay. Mine has the, I don't know what it's called, it's an aluminium with a silicone sleeve, this type of handle. Yeah, and this allows me to get very close to the job. So when I'm working on something, I'm actually holding the soldering iron very near, and because this is silicone, it doesn't get hot. Yeah, this is far better than this type of tip. Yeah, you can get T12s with this type of tip, same bit, fits in here. In this case now you're holding the soldering iron much further back, so basically any movement, especially if your hands, you know, some people are a little bit shaky, then any movement is amplified. Yeah, you can hold this twice as accurately as you can hold that. Simple physics. Yeah, so if you're going to buy yourself a T12, or if you've already got one, you can buy these tips. You can buy them. Just look for KSGR or T12 soldering handles and get something like this. Yeah, they just plug in. Tips, by the way, I use this BC3, a big chunky one. I've developed probably my own technique, and I can do a lot of micro soldering with a very large tip. But there's a number. I won't go into them all because different people swear by different ones. All I'd say is try a few and find what works for you. Yeah. So that's your soldering iron, about 50 euros, something like that. This is my hot air station. It's a Quick 861DW. I've had this for over 2 years now. A very nice hot air station. highly recommended. There is another one now, ATX 862D, which I've never used, but I understand has a performance very much like this machine, and it's considerably cheaper. This was about €230. I think the ATX is around half that price. Yeah, so this one I can thoroughly recommend, and I trust other people who also recommend the ATX 862D, although I've never used one for myself. However, what I have used for myself is this. Yeah, the 858D. There's a number of different makes of this thing. Hot air station. Okay, had this in 2014, and I happily used this for 5 years. Yeah, until I started to do GPU repair. This is not a suitable tool for GPU rework and repair. Yeah, it doesn't do the job. Why do you think I spent €230 on another machine if I didn't need to? Yeah, the answer is because I needed to. If you have something like this, they're not junk. This is not junk, and it's not a toy, and it will do certain things very, very well. Yeah, but GPU and motherboard repair is not one of them. Okay, so get yourself a decent hot air station. You know, they say a bad workman always blames his tools. Yeah, well, if you've got something like this, you're right, it's the tool. Okay, enough said. To finish about the soldering then, yeah, solder. Leaded solder, 6040. This is 0.7 millimeters, and this one is 0.2 millimeters. Yeah, much finer than that one. These two do just about anything I ever need to do. If you can't afford both, get this one, because with this you can do what this will do, but not vice versa. Yeah, so that's solder. Solder braid, I've had various types of solder braid and found for certain types of work I can't do the job very well, and thought there was something wrong with me and my ability, until somebody told me to get some of this. And since I've had this solder braid, I've had no problems. Yeah, Kentromics, number 4 or size 4, and this comes in a pack of 10. So it actually comes in a tin like this. Yeah, I've still got quite a few of them left, and that's what you need. Yeah, believe me, that one. Okay, flux. I've used a variety of fluxes. This is one I prefer. If you're buying some flux, get this one. I actually get some AliExpress. It's very cheap for a couple euros a tube. Quite possibly fake, but it works brilliantly well for me. Yeah, I've had no problem. It often comes with the expiry date, but it works just as well now. It doesn't seem to bother it at all. Yeah. Last thing, you'll need some thermal compound. I use this one just for generic use when I'm actually on repair work. I don't use this once I've actually fixed things. I use this if I'm just sticking the fan on for now. Yeah. On graphics cards, I use this MX4. I'm sure there's others. I also use this for CPUs. It's not cheap, but it's very good stuff. Yeah. So that, and I think that's covered everything that you're going to require. So let's actually now talk about some graphics cards repair. If you watched the intro and you didn't skip to this point, then it's been a rather long time since we started this video. Yeah, so just to remind you, this video is concentrating on 2 cases. One is where you have a graphics card that you have no idea of the condition of the card. Maybe something you bought as spares or repair, or you found at a car boot or a flea market, or even out of a skip. Yeah. The second case is a graphics card that powers up, but it doesn't detect. The PC does not detect the graphics card. If this video goes well and people like it, I intend to make another video on graphics cards that do detect, but then have various problems like don't run once the drivers are loaded, error 43 and similar errors, artifacting, crashing, those type of problems. This video should really help you with pretty much all GPUs made from about 2010 onwards, probably earlier than that to be quite honest. I will probably make another video regarding vintage graphics card repair, which is a different subject. But for this video, we have 6 culprits here. Yeah, this is like the parade of them. Okay, so I'll just tell you basically what we have here. Starting from the front, we have an MSI. This is an RX 460. So that's one graphics card we can look at and we can use to demonstrate certain points. Yeah, that's not working, doesn't detect. This is not quite an old card, just to show this will apply to older cards. This is a HD 2400 256 meg. This is actually working. This rather strange looking thing is actually a GTX 750 with a fan fastened on because the original one was broken, and this is a working card. This beast is an ASRock Phantom Gaming. This is an RX 6800 that doesn't detect. This one is an MSI R9 380 4GB card. Okay, and the last one with a few wires tagged on, which I'll mention later. I've been looking at this graphics card. This is an 8GB R9 390. So that's our parade of suspects. So let's start the instruction on graphics card repair. So you've just got your hands on a graphics card and you don't know the condition of it, but you're quite keen to find out. So you may be tempted actually to just go and plug it in a PC and see what it does. Well, I'm going to tell you now that is a very bad idea. In capitals, don't. I mean, for example, let me just tell you, if you've just, you found a car in a garage, just shed, it's been there for 20 years and you've got the keys, and you don't know what condition it's in, would you kind of get like a battery, strap it to it to jump start it, turn the keys and see what happens? Or would you check if there's any oil in it first? The point is, if you take a graphics card and you don't know the condition of it and you just plug it in, there's a good chance you can make things a lot worse than they are to start with. There's a good chance you may have now, just in one instance, taken a graphics card that was repairable and made it into a graphics card that is not repairable. Okay, so don't plug it in. Once you've realised that, you think, well, what do you do first? And this is the thing you do first: visual inspection. So with the visual inspection, it comes down effectively to see if there's any damage on the card. Yeah, this can cover quite a lot of things. For instance, you might find burnt areas of the PCB. That's something you should be taking note of. Any burnt components, cracked components, burnt areas of the board. I mean, that's quite drastic sort of damage. Yeah. Obviously, we need to be looking on both sides of the board. Another thing you're going to be looking for is missing components. Components that look like they've been broken off the board. So a good visual inspection is really essential to, at first, just get some idea of what condition things are in. It can also save you a lot of time. Spending 10 minutes doing this, although it might sound laborious, can often save you a lot of time when you've spotted something's missing or looks like it's missing, and when you do your diagnosis it brings you back to the same place. You can kind of put 2 and 2 together, yeah, and think, oh, there was something missing, and now you've got an idea what it was. Yeah. Other things you should be looking at is, in this case, I'll ask you, anything obvious you can spot about this board that might make you think something's happened to it at some point? If not, well, are these lined up? No, that one's crooked. That could be one of two things. It might just be effectively, bad quality control in the manufacturer. It might just be made like that. But it might actually be a sign that somebody's taken this off at some time and put it back on, which is a sign that somebody's been previously working on the graphics card. Yeah. So that's another thing you should look for. Talking about previously working, Look for flux and soldering where it's obvious that somebody's, you know, been at something. Flux often will tell you that. I'll give you a few more examples. This actually is another card. This is number 7. I didn't put this out before. GTX 770. Yeah, I don't know the exact condition of this one. I'm not trying to repair it, but what I do know is this has a missing component. You can see straight away here there's a missing component. Now, it might be that that component effectively was never fitted. Sometimes, like say here, you might say there was something never fitted, but there might be other cases that you're more suspicious. I mean, for instance, with this one, there's a chip here, and that one I'll show you under the microscope. You'll see it looks like somebody's cut the legs off something, like something been taken from here. Yeah, you've got a row of these. Like these are all in pairs, and each one's got another chip. So you get 3333, 333. Where's the other one? Yeah. So missing components is another thing to look at. Damage to the PCB. Signs that obviously somebody's been messing. This was me actually working on the repair, but you know, if you see strange things going on, somebody's been messing, and it's important to look. So let's get these under a microscope, and let me just show you a few of the things that you might find. This is the GTX 770. This is number 7 of our 6 cards, yeah. And this is the one I noticed. Just I could feel it really down here. If I just get to where I was, if I follow my finger, yeah. This. So there's a chip here, and I think you can see. Obviously, that's soldered and doesn't really look like anybody's been at it. But this one, I'll find a little pointer actually for this. This one is quite obvious that somebody's cut the pins off a chip that went here, and there's a scratch there on the PCB. Yeah, so this may have cut through some tracks, we don't know, but something's obviously been removed from here. It may well be the same as this chip. We can perhaps look at the board and see if it's like a symmetrical type circuit and think, oh yeah, there's probably 2 of those. But you may have to find out what that was if you're repairing this. You may have to look for photos on the internet, ask if anybody knows what goes there. Yeah. Also on this, we spotted one of these MOSFETs. This clearly looks like it's being desoldered. Yeah. So we know somebody's been here, and we know somebody's been at the other chip. Yeah. These capacitors, these look like they were never fitted. Yeah, you can pretty much tell, especially if you look underneath the board. By the way, this is flux. Yeah, this is a obvious sign that somebody's been soldering here. Yeah, but not on these two. So we can see straight away. In fact, now actually looking at it now, these have been unsoldered. Yeah, although on the other side it looked like nothing had ever been there. Once we flick it over, we can see clearly that something has been there. So this is the sort of thing you should be looking at. I mean, this one's quite blatant, yeah, which is kind of why I added it to the parade of suspects. The little RX 460, this is one I've actually been working on, and I know as a fact that there's a component missing because I've actually taken it off. So again, telltale signs, flux. When you see flux, somebody's been doing something, yeah. Clean the flux off and have a look to see what they've been doing. Even if it doesn't tell you straight away what the problem is, it's something you should, you know, obviously think, oh, well, something's gone here. Somebody's been here by the looks of it. I actually know that I took one of these devices off, but the one I took off wasn't that one. And then you have to think, well, was this, you know, should it be this way? The one I took off is actually here. You see the bad soldering? I haven't bothered to clean it up. Yeah. So stuff like that. I'll clean that up in a minute. That's that one. Something a bit more subtle. This is the RX 6800. Yeah, I think it's a 12 meg card, something like that. Nice graphics card. This one I originally spotted a problem here. Yeah, and I actually found the problem while I was trying to trace what was wrong with it rather than visibly spotted it. If I'd spotted this first, it would have saved me time. Yeah. Eventually I came back to this and then I realised there was more flux here. I've cleaned it up, but you can see something's off here. There's a chunk of PCB missing. You can see there's a pad missing here, a pad missing here. I can actually even zoom in closer, yeah. And just get the focus on it for you. There you go. So this one, I actually found this by search tracing. You can see there's a little bit missing out at the end of the coil as well, like something's hit it, yeah. Looking on the back of this one, I didn't spot this until the guy who actually owns it pointed it out to me and mentioned it. Again, this is the sort of thing I should spot. I'm just see where the damage was. Yeah, it's at this end. This I spotted. Damaged, chipped PCB. Yeah. What I didn't spot, but this is what you should be looking for. Just get the focus. Yeah. As it looks like there's a little bit of work gone on here. Can you see this is like a bit crooked? It just looks a little bit like somebody's been there. And on the back of the board, I think you may it's here. Then just get the focus on his. Yeah, this looks actually this looks okay. This side must be on the front side. Somewhere I saw a wire that had been soldered on. It's hard to see it. I'll have to zoom it in. But somebody has put here. Can you see it now? I'm moving it, yeah? See when I move it? That's a bit of wire that somebody soldered from here to here. So that's the sort of thing you should be looking for in visual inspection. So okay, we've inspected our graphics card. You've got some idea of what you should be looking for. So let's go to the next stage, and that is resistance measurement. We need to take some resistance measurements to check the graphics card now for short circuits. We're basically going to make sure to see if it's safe to put this into a computer, okay? But just before we do that, let's just have a quick look at a graphics card if you're maybe not totally familiar with these, and let's sort of understand what we're seeing here, yeah? This is the RX 6800, and you can see a whole row of coils here, yeah? These are coils, inductors. There's some more here, and there's some more here under this bit of heatsink compound. In fact, there's a couple more here, yeah. And often you'll find next to these inductors are some electrolytic capacitors, okay. These are the power supplies that power up the card. So basically you have voltages coming in, 12 volts and 3.3 volts from the motherboard, or from the ATX PSU as well, yeah. And all the other voltages that the card needs to work are generated on the card, and that's what these are doing, yeah. This also, you see some small ones. There's a smaller one here. These are fairly small under the heatsink. There's another small one here. So the first thing you should do is just familiarize yourself with the main layout, yeah. The big row of these things you find will be powering the GPU, the thing that's taking the most power, yeah. The next biggest row, in this case is 3, will be for the memory, okay, and then all the others will be for various parts of the board. I'll just show you a couple of examples. So we've looked at that one. This one is the RX 460. It may look completely different to the other, but actually you've got pretty much the same thing. This only has power coming in from the PCIe. There's no 12 volt connectors up here, yeah. But again, we can see a row of these coils. Look a bit different with the coils. There's another one here. There's a smaller one here, and that's all there are on this one, yeah. Again, this row, or some of this row, will be powering the GPU. You might find that this one over here powers the memory, or you might find that 3 of these power the GPU and 1 powers the memory. This is a lower power card, so it needs less of these. But again, I'm sure you can see the layout is about the same. Rows of inductor coils and capacitors. Let's just have a look at another one. This is the R9380. And I think, hopefully now you've seen a pattern that we can see on all of these cards, yeah? You get a big row, 1 separate, okay? 2 here, that kind of look like kind of identical, like a pair, yeah? This has 12 volts coming here. Again, it will have power on the PCIe. So the big row will be for the GPU. This one, or quite likely these two together, will be for the RAM. Yeah. If it's these two for the RAM, this might be the memory controller, and then there's a small one here, there's two small ones here, and these will be for other voltages on the board. Yeah. I'll show you one more, something completely different. This is our old graphics card, if you like. Yeah, the HD 2400. But again, you've got a GPU, you've got some RAM on both sides of the boards on this one. Yeah. This has a coil, which is the biggest coil. Again, the power is only from here. So the biggest coil will be the most current hungry load, the GPU. Yeah. There'll be power supply for the RAM, which could be this small coil here. Yeah. It could just be this regulator here. On low power rails, you'll have a voltage regulator without a coil. Yeah. So we can look on the back, and here is any more. Yeah, some more voltage regulators. These things are the metal tabs on the voltage regulators. So all again, these will be generated at different voltages, but we can say for certain this one will be the GPU, and probably the next biggest one we can see will be for the RAM, and then the smaller ones. Okay. So now you've got some idea. Let's keep hold of this one. You've got some idea of the layout of a board, and all graphics cards will have that sort of layout. Yeah. So now let's have a look at some resistances. 3 of our graphics cards have no 12 volt connectors up here. Yeah. So these 3 cards only take power from the PCIe, but even the graphics cards that have the 12 volt connectors up here still take power from the PCIe. The PCIe supplies a power in this area, the first part before the notch, yeah, and the voltages coming in are 12 volt and 3.3 volt. The 12 volt here can supply up to 75 watts of power. So if the graphics card doesn't require any more than that, it won't have a 12 volt connector up here. If it requires more than 75 watts, it'll have one or more connectors up here. The more connectors you see, generally speaking, that means the higher the current draw, or they just wanted to make the graphics card look better than it is. Okay, so let's check the 12 volts and 5 volts first. So 12 volts, any of the first 3 fingers on this end. Yeah, doesn't matter, they're all connected to each other. And here we see a resistance reading. Yeah, it's moving around because there's capacitors charging on the board. But as long as you see a resistance, and a reasonably, this one's like half a mega ohm, that's fine. What you don't want to see is this, a short. Yeah. So as long as you're not seeing that, and you see the reasonably high resistance, that's okay. The 3.3 is actually the 4th finger in from this end. On this one, it's actually the slightly longer one, and that's the 3.3 volts. Again, there's no short. If you slip and go to the next one, normally that's ground. On this card, it actually isn't, I've noticed, but on all the other ones, I think you find the 5th one is ground. Yeah, so you can find ground and come one to the right. So that's okay. Let's have a quick look at the other ones that have no external 12 volt from here. Yeah, so this is the RX 460. Once again, onto ground, onto the end, and you'll see again quite a high resistance in the kilo ohms. Yeah, 4th one in from this end, that's your 3.3. there's no short. The next one is ground. It normally is, it just isn't on that old card. It's not unusual, by the way, to sometimes see fuses in this area of the board, yeah, around the 12 volts or the 3.3, or sometimes in this case like quite chunky 0 ohm resistors. If you find those or a fuse, then you need to check it. Yeah. So what you should find is, we'll go from the 12 volt on this one, and you can see it's connecting to these fuses. Yeah. We want to go to the other side of the fuse, then we should still have the connection. So the fuse, basically, if it's a good fuse, should be a short circuit. Yeah. Or in this case, low value resistors. There's some more here. These are not connected to the 12 volts, but these are connected to the 3.3. So again, yeah, make sure the fuses are good. If you find a fuse that's open circuit, then what you need to do is measure to ground from the other side of the fuse, yeah, or just measure to ground from both sides of the fuse if you're not sure which I mean by the other side. You shouldn't see a short either side. Okay, so that's not unusual to find. We have 4 boards here then that have the ATX 12 volt connectors. Okay, they can be 2 8-ways, 2 6-ways, a 6 and an 8, or just a single one. There's a variety of different possibilities. Yeah, some of these pins will be the black wires ground, and some will be the yellow wires 12 volts. But it's very easy to get yourself confused because sometimes they're not always the same way round. What I actually mean is is the way the plug inserts might not be the same way round. So the best way, until you get yourself really familiar with this, to save getting yourself confused, is just take ATX power supply, which is not plugged in, and we'll insert the cable. Yeah, so this is the 8-way cable. Okay, and now you can see where the yellow wires are. Those are your 12 volts. Look, you'll notice this one's actually a ground. Yeah. And on this case you can see that these top pins here are the 12 volts, and the same if I plugged it in here. Yeah, the point I was making, if I just put that one on one side, is this card. This is the R9390. Yeah, the connector actually goes on the board the other way round, this way up. I can just get it into this slot. Yeah, so now you'll see on this one the yellow wires are at the bottom. That's why you can very easily get yourself confused. So I would suggest you do that. Or if you've got an old ATX power supply or an extension, just cut the end off with a dead power supply, or find a little extension type cable you can use, and then it makes life easy for you. Okay. Now we know which way round the plug goes in this. We know that the 12 volts, and you can mark them if you like, if it makes life easy for you. 12 volts. Okay. The reason you need to check them all for shorts, or at least each plug for shorts, is because they're not always connected together. I mean, on this board I think they actually are. So if we go from here to here, we have a connection. Yeah, so all the 12 volts on this are all connected together. Also, what you would normally find after the connector is either fuses or inductors. And capacitors. These are not a buck regulator. These are not voltage regulators or VRMs. These are filters. Yeah. So you will sometimes find that one 12 volt connector goes to one filter and the other one goes to the other. Yeah. In this case, they both go into the same place. Okay. If you have a serious short circuit, it's possible for these inductors to go open circuit. So what you should do is check from the other side of the inductor to ground as well, yeah, to make sure you haven't got a short. To take the guesswork out of things, by the way, I'll just also mention another way to figure out if these are filters or buck regulators. Yeah, apart from the fact that a buck regulator has a driver chip or some MOSFETs, the other good indicator is the capacitors that are after the inductor. Yeah, these are 16 volt capacitors. Yeah, and these ones, which is a voltage regulator, are 2.5 volt. Yeah, and we can go. These are 2.5s as well. So that's a very good indication, because these are 16 volts, that this is a 12 volt supply. This is the GTX 770. So again, it has 2 connectors up here. I can see the connectors are the same way round, so they're marked, so we know which way they are. For which one's the 5 volts. This also has 2 inductors here. Now with this one, you can clearly see that these are all connected together, the 12 volts, obviously off the same plug. But if you go to the plug, they're not connected. Okay. And what you have here, you have one of these plugs going to one of these inductors. But the other inductor, so the same inductor doesn't go to the other one, it's the other inductor. Yeah. So in this case we have one inductor on each of these, and these will be powering different phases of the VRM. So part of the VRM, it's kind of like maybe divided in half here. I mean, it's only supposition, but possibly these 4 are powered by the 12 volts coming through one of these inductors, and these 4 the other one. Yeah. Again, we'll check to ground. We can check from the 12 volts, or we can check from the inductor. We know the inductors are good. We can measure them. They should be like a short. Yeah. Just get one of these inductors. And to make a contact, there you go. So an inductor is basically to your multimeter, it's like a short. This one to ground, no short, and because it's on a separate supply, it's important to measure that one to ground. Okay, so that's all the 12 volt rails checked if they shorted to ground, but that isn't the end of the story. It's possible for the 12 volts to be shorted somewhere else, yeah, and this is what we need to look at. This is very important. Basically, the 12 volts coming in is the most powerful supply on the graphics card, yeah. This has the most power, the capability of supplying the most current, and it actually has the capability of doing the most damage, okay. If you have a short circuit on any of the 12 volts, whether it's on the PCIe, whether it's one of these or two, or they're all connected together, if you find a short from the 12 here to ground, or from here to ground, the most likely cause of that is blown MOSFETs in these VRMs, yeah. The VRM basically has MOSFETs connecting to the 12 volts and other MOSFETs connecting to ground, and then the junction between the two goes to the coil. And if you have a short circuit MOSFET somewhere in the VRM, or more than one, and it's what's called the high side, that's the MOSFET that's connected effectively to the 12 volts. The other end of it is connected to the coils, and the coils are connected to the GPU, the power rail, the V-core, and to the RAM, yeah. Any short circuit here will basically send the 12 volts directly through the coil to here. So if you find a short circuit on the 12 volt rail, don't think, let's go and plug it in to 12 volts on a bench power supply. Stick 12 volts in and see what gets hot. Yeah. The chances of the GPU survived because the ATX power supply tripped out quick enough when the thing went short, it's not going to survive when you stick 12 volts in off your bench power supply, yeah, and dial it up to a few amps. So if you see a short on the 12 volts, you need to find out why. Don't put power into it. So what we need to do now is to check that hasn't happened, yeah. The way to check that is to go from the 12 volts to each of these coils. Yeah, you got the ones here, you got some more here. This looks like, yeah, that looks like the only ones on here. I'll come with another one. So from your 12 volts to each of these coils here, the ones here, the ones here. This has quite a lot of little ones. So we need to, oh, there's another little one on this. So we need to check from all of the coils to 12 volts. And you need to check to each 12 volt source. So in this case, all these are connected to the same 12 volts. So one check from here, doesn't matter which one, and one check from here. Yeah. On this one, these are separate, so we need to check to the coils from this lot, and from here. Yep, so it's important you know whether these are connected together. Okay, so let's have a go at that. Okay, on this one, the coils are all surface mounted, yeah, so it's easy to test from the top of the board. Sometimes they have pins going through the board and it's easy to test from the other side. So let's start off with this 12 volt supply first, yeah, and we'll just go to each of these coils in turn, and we need to test every single one to see if there's a short, yeah. So you basically go down all of the coils and you check on the board to see if there's a short, yeah, and there isn't. Yep, just let the meter catch up with me. Yeah, so these were all okay. I mean, you could say you could just check one of these because the V-core was all connected together, but I just normally just go down the whole lot and just be sure. I have seen occasionally the RX 6800 is a good example. One of the coils is actually on effect on a different supply to all the others. I'll show you that a bit later. Okay, so again, it's just a matter of going down all these coils, and we have a look to see if any of them are shorted to 12 volts. Yeah, there's another smaller one here. Just get a connection on it. Yeah, and there's that's it for this board. I don't think there's any more. I think that's all of them on this board. Yeah. Once you've done that for this supply, you need to go for the other 12 volt supply and do exactly the same thing. And once you've done that, you need to go to the PCIe 12 volts and do exactly the same thing. I have seen some graphics cards where this supply supplies some of these phases, yeah, so you need to check all of them. If you find any shorts to the coils, then you've got a short circuit VRM, yeah. To keep this video short, which it isn't going to be, but to keep it shorter, I'm going to link 2 videos on how to trace a short circuit in the VRM. Okay, so if you find a short any of the coils to 12 volts, stop this video and go watch the two I'm linking, how to find a short circuit on the VRM. Let's look at one more. This is the R9380. This is the one with blown fuses here, yeah? So again, I want to check if there's any shorts. I can't check from the 12 volts here because the fuse is blown. I need to check from here, yeah? And I need to check on all the coils which are over here, okay? Now, these coils are ones that have pins coming through the board, yeah? So it's be quite difficult to try and effectively hold your meter on here while you're checking. One way to possibly do that is to find somewhere on the other side that's connecting to here first. Yeah, we can have a quick look. I mean, for instance, this capacitor might well be because this is a 16 volt capacitor, so there's a good likelihood, if I just balance this up here, and you won't quite easily see me do this, but let me just see if I can find a connection to this capacitor. Not that end, that end. Okay, so I now know the 12 volts is actually here, yeah, and I'm on the same side as the board. So from here now I can go to all of the coils which are over here, and once again I'll check the shorts. I mean, the fuse have blown for some reason, so have we got shorts on this one? No. 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 That one read a bit lower than the others, though. No, it didn't. I think it's just yeah, okay, we got one that's reading a bit different from the others. Okay. That one reads like the other one that read a bit different. No, it's going up again. It could be due to capacitance charging, but there's no shorts. Yeah, there's no shorts. Are there any other coils on this one? Yep, there's two over here. Yeah, that one and that one. So once again, we have to check from the same thing. From this, we know this is 12 volts out of the fuse. That one and that one. Yeah. So there doesn't appear to be any shorts on this one. There's one more little coil down here on the front side, so with this we can go to the fuses. There's no short there, yeah. And there's one little one down here. There's no short there. So we can't find any short circuits on this one, and yet the fuses are blowing. But now we've checked everything from the 12 volts. But it's possible to have shorts from these coils. These are your voltage rails that are generated by the VRMs to ground, and that's the next thing we need to check. This is the 6800 RX 6800 again, yeah. So we're happy with the 12 volts on all of the boards we've checked. We're now looking for shorts to ground. Okay, so again we need to go through across all the coils and find shorts. We'll start with these ones here. This one's reading 23 ohms, yeah. This one is 25 and this one is 23. I happen to know that the ones that are 23 on this are for the memory. Your memory supply would normally read between about 25, as I'm getting now, up to 100, 120, depending on the age of the board. Older GPUs tend to read higher, yeah. Ones with Samsung memory chips tend to read lower, by the way. Those tend to be about 30. A lot of them reading about 60, yeah. But there's no short on there. The one in the middle, which is a different resistance, this one on this board I happen to know is the memory controller. But it doesn't really matter if you know what they are or not. You're just looking for shorts, yeah. There's some more here. No shorts on that one. No shorts on that one. The little one here. Yeah, no shorts on that one. Another little one here. That one just reads open circuit, which in itself is a little bit unusual, by the way. This one, no shorts. Are there any more I've missed on this? No, but I haven't checked these. Now this lot, this is your VRM. You'd expect this to read a very low resistance to ground. Okay, 0.7. Let me short my meter leads together and see what I actually have. 0.5, yeah. So this on these is almost reading a short. Yeah, but that is quite normal for a modern GPU like this one is. I have another multimeter I tend to use for measuring the VRM resistance, and that's because this one will only go to 1/10 of an ohm. The other one will go down to 1/100 of an ohm. So let's change the multimeter and let's see what we can see then. So this meter will actually read to 1/100 of an ohm if I short together the leads. 0.08, 0.07, 0.065, yeah? That's about as low as it will go. Now let's look on our VRMs, connecting the black lead to ground, and let's see what we have. 0.2, 0.18, minus about the 0.0 we had. So it's about 0.1 of an ohm, this GPU, yeah? So for a very modern GPU, that's quite normal. You may find, I have seen, I'm not sure if this was a board, where one of the coils read a completely different resistance. Yes, this one, 1.7, yeah? Back to 0.2. 0.2, yeah? I've only seen this on this particular card, but what I understand is happening here is that this particular one here is powering a different part of the GPU from all the others. Yeah, so just if you see that, that's probably what it is. If I looked up this controller here, I'd probably find this is 7 phases plus the one which is separate. Yeah, these controllers can often power 2 or 3 voltage rails at the same time. Yeah, okay, but there's no shorts. Let's have a look at a few others. This is a RX 380. This is the one with the blown fuses. Yeah, what's this one showing from the various coils to ground? This one, it's not possible to connect to the coils this side. There's nowhere to connect, so let's turn this upside down. Once again, black to ground, yeah, and I'll use the more sensitive meter. This is reading, trying to get a stable reading on it, 0.01. This is reading practically short circuit on that one, yeah. What's on here? Almost short, very low, yeah, 0.08. So we're getting well down below sort of 0.2, yeah, we're getting some very low resistances on this one. Yeah, 0.15, 0.15, 0.12, 0.1, 0.09. Let me always just short the leads together. Shorted about 0.03, yeah. Once again on these, 0.12. I think this will even show me the resistance of the coil from one side to the other. Yeah, slightly lower. This is reading very low on these. These ones here, the 6, these are all together. This will be V core. This one's separate. You'd expect this to be a different resistance. Like I showed you the memory on the other ones, about 20 something, and this is also very low. That is not normal. We have 2 more inductors over here, which are probably to do with the memory. Yeah, let's look at these two. Practically short circuit again. So this board has short circuits everywhere, basically. Okay. This, we'll check this other one just here as well, just out of interest. 1.8. No, that's actually reading the resistance, okay. I'd say 1.8, it's probably the 1.8 volts rail. That's showing a bit of a resistance. This is a bit of a resistance. Right. If you see something like this, where you're getting you can expect very low resistance on the V core. If you're using, I mean, this is the meter I recommended. It's like €25. You can see it's a very accurate meter, and it's good enough to show you the difference between a short circuit GPU and one that's reading 0.2 of an ohm. Yeah, you can't accept the memory control, which you probably hear is going to be a fraction of an ohm. This should be like 100 ohms or 50 ohms or something. And again, these should be, you know, 30 ohms to 100 ohms. So we know this has serious short circuit in the GPU and in the RAM, and that is why the fuses are blown. That's all the evidence you need with this one. So this one is not repairable. Okay. One last one, same sort of checks from the coils to ground, so you get an idea of what you should find. Yeah. This again appears to have the VRMs here. I can get to the thing. VRM, voltage regulator module, by the way, if you ever wondered, if you didn't know. Is there a short to ground? The meter's making its own mind up. That's 6.5, what is it, ohms? Yeah, 6.5 ohms. That's a fairly low resistance. 6.5. I think, in this case, that's on all of them, yeah? This is the resistance of the GPU. Yeah, they're all the same so far, yeah? What about these ones at the top? Yeah. So this is an older, this is a GTX 770, and this reads about 6.5 ohms, less the 0.5 it reads when it's shorted. So the resistance of the GPU is about 6, yeah? No, I think there's a decimal point out there, yeah? Just check them again. On the ground. Yeah, 6.5. So it's about 6.5. This would be your memory phase. So the biggest one is always the GPU. The next biggest one is almost certainly the memory, yeah? 30 to 100? Yeah? 50? 50, and then we've got the small ones. Small one here. All the smaller ones you expect to be higher resistance. So basically, the beefier the coils, the lower resistance you expect the load to be, because it's supplying more power, yeah? Any more on this one? No. I have spotted that sometimes you'll find regulators that look like this. These can also be worth checking for shorts as well. If you see anything like a metal tab like this, yeah? You tend to find them more on older graphics cards. I've just found one of the old ones, and we'll check some of those as well. Okay, last one. This is an older one. It has one buck converter, and this will be the GPU. Yeah, 14 ohms, so older. It's reading higher. It's quite normal. This might be a memory one or something else. It's quite high. So that's what's over a kilo ohm, yeah. And this has these other type of regulators. So if you see these, just check either end to ground, yeah. That's reading 88 ohms, yeah. That's almost certainly the RAM. 24 ohms this side. No, 20. That's kilo ohms. Just check on the meter. And this is ohms, yeah. So 85 ohms. RAM, it's fairly typical, yeah. 10 for the old GPU. Okay, some more regulators on the back of this one. Quick look at them. Just check one end. Yeah, quite high. I'm expecting these would all be quite high. Okay. Very high. Quite high. Quite high, yeah. Okay, so that's enough resistant measurements. I'll just mention one thing. We know if there's a short on the 12 volts on these, it's almost certainly blown FETs or blown drivers, and you need to investigate that, yeah. And I'm going to link some videos how to do that and how to trace short circuits, yeah. If you find on these smaller rails low resistance on the memory phase, if it's less than like about 25 ohms, I would say you've probably got faulty RAM. If it's like 0, you've got blown RAM, yeah. If you've got blown RAM, you'll have a blown GPU almost certainly. The card can't be repaired. These little regulators, one down here near the 3.3, this is normally a 1.8 volt supply, yeah. If that's got a short circuit on, you can pretty much say it's a blown GPU, yeah. You'll have another look around. On this one it might be this one, which is about a 0.9 or 1 volt supply. If that's short circuit, it's going to be the GPU again. So the 1.8 is short, the 1 volt is short, the memory is short. And remember, this will read very low anyway, but it shouldn't actually be short. You know, anything less than about 0.2 ohms, I would think. All those are going to lead to a blown GPU and a card that can't be repaired. So far then, we have one card which we can't be repaired. We've diagnosed the problem with this one, the R9380, and that is it has very low resistance on the RAM and the GPU. So this is exhibiting short circuit RAM, and quite possibly a short circuit will damage the GPU as well. So this one isn't repairable really. We didn't see a short on the 1.8, and this is possibly the PEX, the 1 volt. But if you do see a short on those voltage rails, that also points to that the GPU is blown. Yeah. Just a couple of points I'll just mention. When you're measuring resistances on these cards, make sure you're using your meter in resistance mode. Now, some people say don't use it in continuity mode because continuity mode will show a short everywhere, but that isn't actually really the case. With this one, when we go to the continuity or bleeper mode, basically, if we press select here, this puts into ohms range. Yeah, I'll just put a light on as well for you to see it even better. Yeah, so I've got a bit of illumination here. Yeah. So this is now in bleeper mode, but it's actually in ohms mode. This will not show a short everywhere. If you go into diode mode, then this effectively is where you'll see shorts everywhere. Yeah. So if we just go to the GPU on this one, I'll just go from one of the coils to ground. This is now reading 0. Yeah. If I just come back out of that mode and go into continuity mode in ohms, which is this one, yeah, it won't show 0. Yeah. It'll show the same resistance it was showing before, just give you a bleep. So it's not true that using continuity mode will show a short everywhere. It's showing using diode mode that will show a short everywhere. Same on the flip, by the way, just the same. Continuity mode, yeah, I'm in ohms range. It's now I just untangle the wires, there we go, and it's bleeping, yeah. And if I measure the resistance, I'm in continuity mode and I don't see a short. Yeah, if I hold the button 3 times on this one, it's now in diode mode. This is where it'll see a short. Yeah, so by all means use continuity mode, just don't use diode mode. Okay. The other quick thing I'll mention, if you've got a short circuit from 12 volts to any of these coils, if you're interested to know where the current is flowing, in fact where the short is, I mentioned you can't just go sticking 12 volts in here off your bench power supply, yeah. But what you can do is you can feed into here a low voltage, 0.5, 0.6, something like that. That's lower than any voltage that would ever exist on the working card. If you put say 0.6 volts in here, yeah, you can then go to all of the coils on the board here and the ones over here and measure the voltage on the coil. Yeah, if you see a voltage on any of the coils, that's where your short is. So that would help you, for instance, to determine whether your short is from 12 volts to the memory phase, or whether your short is from 12 volts to V-core, or whether it's to the memory controller. Yeah, that's how you would do it if you have a short from 12 to any of the cores. Unfortunately, I don't have a card that has that problem at the moment, so I can't demonstrate that, but when I do have one, I will make a video and I'll link it to you. Likewise, one of the regulators will be generating a 5 volt supply from the 12 volt. It may be a regulator like this, it quite often is. It could be a little inductor. Yeah, if you have a short on the 5 volts, then that rail is probably supplying some other voltages on here. So again, don't go sticking 5 volts in there to see what gets hot. Yeah, stick about 0.6, 0.7 volts in, and then check on the other inductors on the 1.8, on the PEX, see if either of those inductors have any voltage on. If there's anything getting there, that's where your short actually is. Yeah, And the last is the same again on the 3.3. It's quite often that the 1.8 is generated from the 3.3, it could come from the 5. Also the 1 volt or 0.9 volt could come from here. So again, if you've got a short on the 3 volts, by all means put about 0.6 volts in with your power supply and just check on the other coils to see if there's a short on the coils. Again, that will find where the short is for you. Okay, that's enough on resistances, a little bit about how to trace them and what to do in the case you find a problem. So assuming now that your card has no shorts, then the next thing we need to do now is to go and check some voltages. So GPU voltages. This information is a little bit generic. It won't apply exactly to all graphics cards, but this will mostly apply to most graphics cards. You may find some variations, but if you understand what I'm going to show you now, then you'll be able to handle the variations and know what you're looking at and understand the variation basically. So the first thing you need to understand is with a graphics card, when you power the computer up, there are various voltages after a period. It has to have power to the memory, to the GPU, and to the interface that connects to the PCIe, and the BIOS, and various other parts have to have power. And these power rails don't come on all at the same time. It doesn't not a matter like you just plug it in and instantly everything appears. They have to occur in a certain sequence, and this is for a number of reasons, but a good one is, if you imagine, there's no point the GPU having power and trying to talk to the computer if the PCIe interface has got no power, because it can't. There's no point the GPU being on and running if the BIOS has got no power. So the things have to switch on in a set order. It varies slightly between AMD and Nvidia cards, AMD being slightly more complicated, so that's the one I'm going to show you first, and then I'll explain why it's a bit simpler on the Nvidia cards. So let's start from the beginning then. When we turn the computer on, there are two voltages that appear from the motherboard, from the ATX power supply. On the PCIe connector here, on the 4th pin in, you get 3.3 volts from this end. The first 3 on this side gets 12 volts, and for that matter, if you turn it over, if you ignore the first pin, the second and third one in here is also 12 volts. These apply power to the board. This 12 volts can supply up to 75 watts of power, so if the graphics card needs more than that, it will have extra connectors up here, 6 and 8 way. The more connectors presumably is the more power it needs, and these also supply 12 volts. So we first switched on our card, and let's look at that. We know coming from the PCIe we've got 3.3 volts, and we've got 12 volts. Okay, these are both coming from the PCIe connector. On some graphics cards, I mean all the high powered ones, we've also got 12 volts coming in from the ATX on the 6 and 8 way connector or connectors. So that's what's coming in, 6, 8 ways. So once the power appears, the first thing that will occur is that the 12 volts then generates a 5 volt rail internally on the card. This is normally, I'd say pretty much always done with a voltage regulator, which is a 3-pin device. It has 12 volts coming in on one, a reference voltage on another, and an output on another. And the reference voltage effectively sets the output voltage, so that just appears. It could be 12 in, ground, and 5 out. It depends on the regulator. But that's what happens when you first power the card up. Okay. What happens next is that there is some logic circuitry on the board that checks that all these 3 voltages are present, and if they're all present, it generates a signal. A signal is like effectively just a voltage going from the logic circuitry to another part of the board, and this signal is called 1.8 volt EN, 1.8 volt enable. And that will be generated by some logic circuitry. Now you might wonder, where is this logic circuit, because we're going to talk about it quite a bit. Let me zoom down on a couple of boards and I'll show you where this happens. So on this RX 6800, yeah, this is your 12 volts coming in. The logic circuitry is all in this area. The little 3-pin devices here, these are transistors, yeah, and these 6-pin devices are probably dual transistors. The logic basically comprises of single transistors, dual transistors, and sometimes something called a logical AND gate. What a logical AND gate is, it has 2 inputs and 1 output, and when there's a voltage on both inputs, it puts a voltage on the output, but only if there's a voltage on both inputs, yeah. So that's the sort of component you'll find down here. Okay, that's one. I'll just show you another one. This is the RX 460. In this case, it's all around here, the circuitry. Yeah, you can see all these devices here. Once again, you can see a number of single transistors, a 3-pin, some dual transistors, these with the 6 pins on. This is where I've been working on this board because there's a fault in this area on this board. Yeah, and again, you could find logical AND gates. They're normally 5-pin devices with power and ground, 2 inputs and 1 output, and there's only a voltage that appears on the output when there's a voltage on both inputs. So that's where the logic circuitry is. So now we understand that, let's go back to our bit of paper. The logic circuitry, one of the transistors basically will output a voltage. It could be 3.3, 5 volts. I mean, it's not really important what the voltage is, but it's not 0 volts. Yeah, it outputs a voltage, and that voltage goes to the chip that generates the 1.8 volt. Now, where I said the regulator that generates the 5, or there could be, by the way, on some motherboards I just mentioned, there could be 2 5-volt regulators. Yeah, one of them powered from the 12 volts here, and one of them powered from the 12 volts here. You will find that sometimes. It doesn't really affect what I'm discussing, but you will find that. Okay, so the logic circuitry, by the way, it might be looking at both of these, and that's why it knows you've got 12 volts coming in on the PCIe, but you haven't connected these cables, possibly. Yeah. So this 1.8 volt enable, we'll come back to this. This voltage regulator is just an automatic thing. It's no intelligence to it. If there's 12 volts coming in, there's 5 volts coming out. Simple as that. Your 1.8 volts is generated normally by a buck regulator. That's the type that has the little coil. Yeah. Or sometimes what's called an LDO. There's 2. Yeah. So buck, which has a coil, and LDO, low dropout linear regulator, that doesn't have a coil. This is just more efficient than this. You tend to see this if there's more power being drawn from the 1.8 volts. Depends on the graphics card. Okay. Your buck and your LDO regulator is a little bit more complicated. Normally this is generated from the 3.3, almost always. So this regulator, I'll draw it, has 3.3 volts coming in, yeah, and it has going out 1.8 volts, yeah. It may well have a power pin called VCC, or maybe it comes from the 3.3, which is power. This could be from the 5 volt, or it could just be from the 3.3. It has another pin called enable. Okay. And for this to switch on, okay, the 3.3 is there, you're on, yeah, your power's on, there's nothing coming out of it. For this to switch on, it needs to be enabled, and that's what this signal does. So that logic circuit generates a signal, 1.8 volt enable, and that goes to this pin. So when there's a voltage appears on here, this switches on, okay? And we've now got 1.8 volts, okay? The 1.8 volts is there. What happens next is, for the next voltage rail to switch on, it needs to know that the 1.8 is on, okay? And the way it does that, there's yet another pin on this regulator, yeah? And this is called P good, normally power good, yeah? Power good. And that comes back out of here, yeah? The enable's going in, yeah? When this is switched on, it generates this power good coming back out of it, okay? And this goes to the next voltage rail, which in our case is PEX. PEX powers up the part of the GPU that is responsible with communicating with the PCI Express. Okay, that's what PEX is. By the way, the 1.8 also powers up part of the GPU and generates some voltages for various parts of logic circuitry. The 5 volts generates power for the logic circuitry, okay, or the 5 volts, yeah, for the logic circuitry. That's what they do. Okay, so we have to tell the regulator that generates the PEX that the 1.8 volt is working, and that's what this does, power good. So this goes to another regulator, okay. Coming in, could be from the 12 volt, it could be from the 5 volt, it could be from one of the supplies, yeah, but there's a voltage coming in, yeah. It doesn't really matter what it is, 5 volt, 12 volt, 3.3 volt, depends on the design, but one of these voltages is coming in, yeah. Going out, we need PEX, which is 0.9 volts to 1 volt normally, yeah. This regulator is like this one. It also needs VCC. This is its power, which could come from one of these, the same, or it could come from a, you know, it could have a 12 volt input and a 5 volt VCC, but it needs them both, yeah. And then once again, it needs enable. So when the 1.8 volt regulator, that's this one, yeah, generates a power good, that goes to this enable. It may not go directly, by the way, it can go through a number of other transistors. Don't consider this is necessarily just a piece of wire, yeah, or a circuit track. There's probably some logic in between, yeah. And again, there's probably some logic, and by logic I mean some transistors, yeah, that quite often make other checks at the same time, yeah. When the logic is happy, and again you know where the logic is, yeah, it generates it sends a voltage to the enable pin on this one, yeah, and this one turns on PEX, and we've now got 0.9 volts, okay. Same as this one, when PEX is enabled, it now sends out a power good, P good, power good, whatever you want to call it, yeah. Okay, so this is just step by step, yeah. The PEX voltage, by the way, I mentioned powers up part of the GPU that talks to the PCIe down here. Okay, so the next thing that happens after that is that we need to turn on the AMD. We need to power up the memory. Okay, the memory is normally like a multi-phase. On this one, it's the 2 outside ones. On some, it might just be 1. But between 1 and 3 normally phases power up the memory. Okay, so again it has a controller, voltage for the memory, yeah, VRAM if you like, yeah, and the controller again through some logic, so normally not just connected one to the other, but through this various logic we'll put the power good on this one, yeah. Again, it's like the other, so you know what's happening here. This has got power coming in. This is normally from the 12. This is always from 12 volts. Yeah, 12 volts power coming in. It'll have VCC, which is power to this chip, which could come from, you know, various voltages, but it will have it. Yeah, and coming out is VRAM, your voltage to your RAM. Yeah. This then powers up your memory chips. Okay, all these things around here, okay, all these things here and on the other side, no, just one side on that one. I did have a card somewhere, yeah, this one on 2 sides, okay. So that powers up your memory. So now we've got power onto the interface to talk to here. Your BIOS, I mentioned, by the way, runs from 1.8 volts. So the 1.8 volts, this also powers the BIOS. Okay, that powers your BIOS. So that's got power. Your interface has got power. Your memory is now powered up. Yeah. So coming out of here again is a power good. Yeah, another power good signal. Okay, and this goes to the VRM, that's like the big multi-phase one that's powering the main V core for the GPU. Yeah, on that there's 7, I think, plus one other. This has got 3 plus 1. Yeah, the one is the memory controller, by the way, and on this I think the one is the memory controller. No, the memory controller's here on this one. I'm not sure what the other one is. So this goes to your VRM, the big one, the multi-phase. Yeah, and again, this is your controller chip. Yeah, controller, and you know what's going to happen straight away, don't you? You've got 12 volts coming in. Yeah, you may have VCC, power to the chip itself, which could be 5 volts. You know, could be 3.3. Depends on the chip. Yeah, and then this power goes to the enable on this one. Yeah, it enables this one coming in. Did I draw the enable on this one? I should have done. Enable. Yeah, power goes to enable. Yeah, this now powers up your GPU core and your GPU memory controller. Yeah, which is the interface between the GPU and the RAM. There's also power that powers up the HDMI and DisplayPort connectors as well, yeah, and that will come on at some point during the sequence. But that is basically how it works. This then doesn't need to have a power good. You may well have a power good pin coming out, but it doesn't need to switch anything else on because everything's on now, yeah. So that is how it powers up. And the last quick thing that I neglected to mention, but it's actually obvious from what I've just shown you, but this is just to reinforce something, yeah. Your GPU chip, the big square thing in the middle of your board, yeah, your GPU. As I've just explained to you, the GPU does not just have a power supply rail, yeah, it has variouses. It has V core, yeah, this is the 0.8. It has PEX that controls a part of the chip that's responsible for talking to the PC. It has 1.8 volts, amongst other things is the part of the chip that's responsible for talking to the BIOS, and it has the voltage for the memory control, yeah, mem control, which may be the same as V core, it might be slightly different. This is why when you do the resistance checks and you find a short circuit on 1.8, PEX, V core or VMEM, almost certainly the GPU is the fault. Yeah, that's why I mentioned it on the resistance, and hopefully now you can see exactly why that is the case. Now let's have a look at how to represent this on the chart. This then is a power sequence chart. Yeah, this is telling you for Nvidia cards, for most of the AMD cards, and some other of the AMD cards. Yeah, this is the one we've just looked at on our diagram here. So what this chart basically does is explains the sequence of this happening, but as a graph. Yeah, so these vertical lines effectively are different times. So these steps occur one after another, as I've just explained on the graphic. Yeah, so in this case, when you first switch it on, you switch your PC on, yeah, you get 12 volts and 3.3, yeah, and automatically the 12 volt generates the 5 volts. When these 3 voltages are all present and stable, the logic circuit will then generate this signal 1.8 V enable, which is to enable the 1.8 volt regulator. So that signal goes to the 1.8 volt regulator, as I've just shown you, yeah, and it turns on. When the regulator is generating 1.8 volts and it's stable, it then outputs this signal, 1.8 V PG, the power good signal coming out of the 1.8 volt regulator. That goes to the regulator that generates the PEX voltage, PEX VDD. PEX VDD switches on. This is your 0.9 volts roughly, yeah, 1 volt sometimes. Okay, and this voltage generates powers the PCIe interface in the GPU. Again, once the voltage is present and stable, the regulator chip, the controller, generates this signal, PEX VDD power good. Okay, that comes out, and this goes to the enable on the memory voltage supply, which is sometimes one phase of a buck regulator, sometimes 2 or 3 phases. Okay, this enables this regulator, which switches on and starts to generate VRAM, which is about, say, 1.35 to 1.5 volts. Yes, normally. On older cards it could be different. Okay, again, once that is stable, this controller then outputs this signal, MVDD, power good. The memory control voltage is good. And this goes to your last regulator. This is the big one with lots of phases that powers your GPU core when it switches on. And it turns on 2 things at the same time. It turns on the core and the memory controller. Yeah. So that's basically how that works. So 1.8 volts, PEX volts, memory to the RAM, and then memory to the core and to the memory interface built onto the GPU. Okay, that's how it works. This is the same sort of thing but for Nvidia cards. Yeah, this is true for the 1000 series upwards, 2000, 3000, but probably also true for like the 900s, the 700s and older ones. Yeah. So in this case, much the same. 3 volts, 3.3 volts and 12 volts comes on when you switch on, and that generates 5 volts. On some older boards it also generates a 7 or 8 volt voltage. Yeah, that again powers some of the logic circuitry. And by the way, I have seen the 7 volts. I think I saw it. I'd have to double check on one of the AMDs, but I have certainly seen this 7 volts. Yeah. So these voltages all come up. Yeah, and when they come up, the logic circuitry then switches on the 1.8 volts, same as this. Okay, the 1.8 volts comes on and stabilizes and generates this signal, NVVDD, enable. This is the enable signal going to the multi-phase controller, the big one with all the phases on, that generates vCore. Yeah, and it goes to the enable pin on this and switches it on. Again, there's logic circuitry involved to check in, everything's present. Yes, we can now switch this on. Again, that comes on. Yeah, and we've now got vCore. So this is around 0.8 volts. Yeah. The controller, once it's happy, it's stable, sends out the signal NVVDD, power good, P good. Yeah, and this goes to your PEX controller, so it's a different order. Yeah, it also goes to your VRAM and memory controller. Yeah, and these pretty much switch on at the same time. One comes slightly before the other. You can just see it's a slight difference. Yeah, but this basically enables both these to come on. Okay, these come on, so your PEX voltage comes up, which is the PCIe interface in the GPU. I said it before. And this one, FBV DDQ, this is your core voltage and also your memory controller. They're effectively the same thing on an Nvidia, where they're separate on an AMD. Yeah. This last one, by the way, is for the RX 5700 to 6800, all those sequences, and it's much the same. Different names of the signals, but they're still the same things. Yeah. The only real difference with this is rather than having the PEX voltage 0.9, it has a 0.75. Yeah, and I believe that 0.75 also powers up the circuitry for the HDMI and the DisplayPort connections as well. So that is a power sequence chart. Yeah. If you want to snapshot that on the screen, I'm sure that'll help you a lot when we're trying to work on these cars to see where the problems are. I just realised I spoke out of turn slightly there, by the way. I wrote it right and said it wrong. So just to clarify on this one, yeah. After the 1.8 we get the vCore, yeah. Then we get the PEX, and then we get the voltage to the RAM and memory controller. I said vCore and memory controller. This is voltage to RAM and memory controller. Okay, that was just a little error I made, but I had written it right. Now then, we know what voltage to look for. We know in what order they occur. Yeah. So let's have a quick look at a couple of boards now and have a look to see what these various voltage regulators look like. The most obvious, of course, are the VRMs, the buck controllers. Yeah. The big one, you know what it is now, vCore. Yeah. And the controller chips, this actually has drivers. So these are drivers. Sometimes there's 2 or 3 MOSFETs. Sometimes they're built into one driver. Yeah. And the controller for this will be almost certainly this thing over here. So this is controlling each of these phases, and the effectively all triggering in turn, running round and round in a sequence. Yeah, a bit like cylinders in a car firing in a certain sequence. Okay, but the controller will normally look like a square chip, something like this, and it may be in some cases on the other side of the board. Yeah. These are also VRMs. Yeah, again we've got drivers. There's a very good chance that's the controller, the square thing. If they're multi-phase, looks like a square thing. The way to be certain is to read the part number and then go find a data sheet. So you Google for the part number plus the word data sheet, and you have a look to see if that's what it is, a multi-phase controller. Okay. This small one here on its own, actually the controller is missing. It's there. That's the first problem on this board I'm actually repairing. Okay. This one here, probably the 3.3 on this one. Normally the 3.3 is somewhere near to here, yeah. And this appears to have a buck regulator, and the controller is probably this chip, or it may be on the other side of the board. Again, we have to have a look for chips around here, and then go and Google for the part number and see if it's actually a buck controller, yeah. But it could be this one. What else do we have? A few more. Buck coil again, probably the controller. Again, look up the part number and have a look. Yeah, also have a look on the other side of the board. Yeah, this could also be a controller, so you know we need to have a look. Again, look up the part numbers. Yeah, let's look at another board. This one, right? This one has the individual MOSFETs in pairs, one for each of these phases. Controls the square thing nearby. This coil here, almost certainly this is the controller for it. This looks like it's got a couple of FETs, so this probably is a buck controller, and that is probably the controller. Again, you'd have to look at the part number and have a look. Yeah. On this one, by the way, the 3.3 volt, you'll notice there isn't a buck controller down here. This is an LDO, linear dropout. That's the controller on this one. I found this one by looking up the part number again and see what it is. Yeah. Once I found this, by the way, I could then find the 1.8. I couldn't find the 1.8 originally on this card. Once I found the data sheet, I just went on the pins. I found a 3.3 coming in and 1.8 going out. The 5 volt regulators often look like this. Remember I said this is not intelligent, it just has 12 volts coming in, 5 volts going out. Normally on either end you'll find 12 volts in, 5 volts out. No logic, it's automatic. That's that, yeah. So you often find the 5 volt regulator looks like this. Can we see one on this board? Look underneath it. So spot the 5 volt regulator on this one. Probably here. I'd have to measure it. But again, just by looking for these things, yeah. And again, measure. If there's 12 volts on one pin and 5 volts on the other end, it's your 5 volt regulator, yeah. And as I said, you may have two of them. You may have one on the other side of the board as well. One more. This is the GTX 750. Buck controller. Two more buck controllers and MOSFETs, yeah. One of the two will probably be the V core, and the one will probably be the VRAM. There's another little one down here, which might be PEX. I mean, you just get this may well be the 5 volt regulator, neither to the 12, or it could. I doubt it's the 3.3. There's another little coil here, somewhere near to here. There will be a controller, probably that. Yeah. Well, this may be for this. Sometimes you find one controller is doing more than one phase, yeah. And sometimes you find the controls on the back of the board. So it's a case of just looking around. You know, once you know what voltage you're trying to find next, have a look to see if you can find it. Yeah. Another good hint with this, I came across this one on a certain repair. I had 12, 3.3, 5. I couldn't find the 1.8, but I had PEX 0.9. And by basic logic, because I had 0.9, I must have somewhere the 1.8. It's got to be there, otherwise this couldn't be there. And that was actually on this little card, yeah. And that's how I actually found that this was the regulator for the 1.8. Just by, well, I know what I've got. It must be somewhere 1.8, and then I found it. Yeah. Okay, so now I think we do know enough now to actually start measuring some voltage on some of these cards. How you decide to work on GPUs when you're measuring voltages and diagnose them is entirely up to you. Some people I've seen literally put the card in to the motherboard, and they start probing around it. I find that extremely difficult, especially on the back of the board, because the fan's in the way normally. Yeah. So I devised a different method, and this is also particularly so because I'm making videos, which makes this method even more difficult. Yeah. So the way I do it is to use just an extension, a cable like this. This motherboard, by the way, is a LGA 775. It's a Core 2 Duo. It's nothing fancy. It doesn't have onboard graphics, which sometimes can be rather useful when you're doing this. But then there's advantage of having boards that don't have onboard, you know. So there's advantages both ways, yeah. But this is what I'm using to test most graphics cards. And I use an extension, and then I use this, which is nothing technical. It's just a cardboard box. Yeah, I've cut out various parts of it. And the idea of this I made in great Blue Peter tradition. That'll mean something to the English viewers. Blue Peter, or maybe you're all too young. It was a TV series for kids in the 70s and later. But I was too old then to watch it. Where they would make things out of washing up liquid bottles and cardboard and sticky back plastic, as they called it. God knows where you ever got sticky back plastic. We couldn't afford it if we could even find it, but always seemed to be necessary. Anyway, this is the way I test them. This is quite a simple one because it doesn't have any external connectors on. Yeah. So let's power this one up and let's have a look at the voltage that we actually find on this GPU. So we'll power this up. Normally I try to put some sort of heat sink onto the GPU, just what I'm testing. Yeah. Sometimes this, which I just balance on. I have another one with a fan on that I use. This one, which I can power from the chassis fan on the motherboard, yeah, and I can rest it on the GPU. But this one's difficult to do. I can put this thermal pad onto it. That's sticky, yeah. And we can, just by feeling this, we can see if it's actually getting warm. That'll help to at least give it a little bit of cooling, yeah. So let's switch this one on and let's have a look to see what we can find. So the black lead goes to ground, yeah. The meter is on DC volts. We've just heard it bleep. I hope you heard it, saying that you can't find it, yeah. Nothing detected. So first place I will go around this, yeah. Let's see if we can find the 3.3 and 12 volts coming in. Probably good places is low value resistors near to the PCI connector, yeah. 12 volts. 3.3 volts. Yes, we found those, okay. We can now look around these buck regulators, so we can go on to the coils. Is probably the easiest place to get to. If you can't on this one get from this side of the board, you can flick it over, and I'll just move the camera and we can check from the other side of the board. Okay, so I've got it the other way up basically, yeah. Again, I'll connect my ground lead, I'll hold it in place, yeah. And we can look on these inductors now. So here we should have V core, and there's nothing here, there's nothing here, there's nothing here, there's nothing on any of them. There's another big inductor somewhere on this one, yeah, over here. Nothing, yeah. So all these big coils, these ones and this one, there's nothing happening, yeah. There's another smaller one here, so let's have a look at this one. So again, ground onto this coil and see if we can see anything. Can I get to this one from the side? And we have 0.89, almost 0.9 volts. That's the PEX supply, yeah. We've got PEX. Let's check the 5 volts, but we know if we've got PEX we must have 5 because the chart tells us so. Well, let's have a look. So I'm on ground and let's look at this regulator. Anything on this one? Thought it would be. Let's have a look. That's 12 volts coming in, yeah? And I'm pretty sure this would be 5 volts going out. No, maybe it's the middle pin. Yeah, 5 volts going out. So in this case, it's in on this end and out on the middle. See, it's not always the two ends, yeah? But that's the 5 volts. 12 coming in, and on the middle pin or the tab, 5 going out. Okay? We know we've got PEX, and that chart I've just shown you tells us if we've got PEX, we must have 1.8. And this is on the one I couldn't find originally, but I can actually show you where it is. The 3.3 comes in on this chip here. Just get a connection on it, and the 1.8 comes out. Yeah, so that's a 1.8. So if we just refer quickly to our chart, we've got everything up to PEX, and after PEX we've got nothing. Yeah, no V-core, no voltage to memory. So we would know, looking at this one straight away, that PEX is the last thing that is actually active. And the problem is either we haven't got the power good, or this voltage regulator for the memory isn't enabling. It's got no enable signal, yeah? I actually took a photo of this one, and this is something I suggest you do, by the way. When you're measuring voltages, either, you know, print a picture like I've done, or do it with some sort of graphics editing program on your computer and keep them, yeah? So you know for a card what you've got. This will help you if you come back and look at it later and you can't remember what you had. And this also remember if you see another one in the future, yeah? So at the moment, this is what we have on this one, and as I've just shown you. This shows you what voltage, the resistance, and we've got 0 volts on the core, yeah? Resistance on what I think is VRAM, or it could be the memory controller, 0 volts, yeah? I found 3.3 volts down here, just poking around. There's 12 here. So this regulator, by the way, this one, which is here on our board, yeah. This is the regulator that generates the next missing voltage that we want, yeah, which is the VRAM on this board, yeah. And I actually poked around this a little bit further. I had a look and I found I've got VCC, I've got power to it, yeah. There's power to it, but there's no enable. The enable's low, yeah. I did this from just looking at the data sheet for this regulator, yeah. So I know why I don't have any VRAM. This regulator's not being enabled. I then actually diagnosed this one a little bit further and found that the controller for the PEX, the power good is there. So somewhere between here and here, I have power good, but I don't have enable. The signal's getting lost somewhere between the two, yeah. And as far as I am with this one at the moment, as I showed you earlier, there's some problem in the circuit down here in the transistors. This is the logic area. Okay, so that's one example. And what do we know with this one? We've got everything as far as PEX and nothing afterwards. And there's a problem somewhere between the power good coming out of here and the enable getting into there. So just a few voltage measurements can tell you a lot. Let's look at another one. Okay, this is the RX 6800, yeah. I've just switched it on. Always check to see if the GPU is getting hot, by the way. This one's quite cold. Probably actually the first voltage you should check is probably V-core and VRAM. Because if there's no V-core and VRAM, this will not get hot. There's no power getting to it. So let's have a quick look on this, yeah. V-core, nothing, yeah. VRAM, nothing, yeah. V memory controller, nothing. Just the big coils. So there's no power getting to the main part of the GPU. So this won't get hot. Now we don't have to worry about that. Let's have a look around the board, yeah. So on this one I have 5 volts, so that's a 5 volt supply, yeah. I said sometimes there's one in this area of the board. That's a 5 volt supply. This one over here, this is your 12 volts. This is on your 12 volts coming in, yeah. It's a 12 volt rail. This one here, let's get onto it, has 0, yeah. There's nothing on that one. Memory control and such like, they're all 0. We've just done that, yeah. This one's 0.75. This is like PEX plus the display circuitry on some AMD cards and some Nvidia as well, yeah. This is your 1.8, so we've got 1.8, we've got PEX, yeah, but we don't seem to have anything else. The way I diagnosed this one, to the point I did, is because I have a coil here, which I don't know what it is, but there's no voltage on it, yeah. And it's not part of the V core or the VRAM, so we can assume that for this to power up, that power supply should be running. Whatever it is, it should be running, yeah. The reason we know that is the designers don't put these voltage regulators on here for nothing, yeah. They don't put one on there that isn't doing anything. So if you find one with nothing on it, and it's, you know, you can't explain it, like for instance, like on the previous one, there was no VRAM, therefore there's no V core, yeah. In this case, I thought, well, what's this strange voltage regulator on here with nothing, yeah? And what I had to do with this one, and sometimes you have to do the same thing, is I went on the internet and I found an image of one of these cards which told you that what the voltages and resistances should be, and told you what the things were, yeah? And I compared this to my card. So, over here, 5 volts, and I've got 5 volts, yeah. These are your memory controller, your RAM voltage, and V core, yeah, and I don't have any of those three. 1.8 I have, PEX, or similar to PEX on this, the 0.75 I have, yeah. And this should be a 5 volt supply, and it's not present. And once I zoomed in on it, I realised the control was missing, yeah, that's what's wrong with it. And this is actually now waiting for parts, and I need to do some circuit board repair here and then see what will happen after that, okay. So in this case I found it because I've looked up some information, yeah. And if I just find the other picture, this is my board. 0.75, 1.85, damaged 0 volts, yeah. And I don't need to worry about anything else because I know there's a problem here, yeah? All the rails are 0. I suggest you do this, and also do this for any working boards you find or any that you've repaired, and keep these, and then you'll gradually build up a reference for when you find another board. You'll know what to look for. If you don't have that, go on the internet and have a look. I think I googled for something like RX 6800 voltage rails and just found it, yeah. The power sequence for this doesn't mention the 5 volts apart from this USB 5 volts, yeah, being present. It doesn't really mention it as such, but I took the assumption once I knew that 5 volts was missing that that's what the problem is with it, and that's why it's not powering up. Okay, let's look at one more or two more. This is the GTX 750. This is actually a working card, and you should hear one beep in a moment when it powers up. It's coming on. Yeah, one beep there. Okay. This one, again, we can have a quick look. So, we have a little regulator at the back here that's easy to get to. Let's have a look at this. So this has 1 volt on it, just over. This will be the PEX, I'm pretty certain of that, yeah. We have a voltage regulator down here. Let's have a look. So one end's got 12 volts, the other end's got 5. So this is a case, one end in, other end out, yeah, they do vary. We have an inductor coil here and 2 more here. So chances are these are the V core and this is the VRAM, but I can't easily get to these coils. They're not surface mounts. So what we'll do with this one again is we'll just flip it over, yeah, and let's have a look on the back where the pins of the coils are coming through. So these are the 2 that were together, yeah, 0.93. This is the same, yeah. So that's your V core, yeah, and there's one other coil somewhere, yeah, over here, big chunky one, yeah. This probably be your VRAM. Yeah, 1.5. So VRAM 1.35 to 1.5, depending on the age of the card. Maybe higher on older cards, yeah. So we know we've got V core, we know we've got VRAM, we know we've got 1 volt PEX, yeah. We found the 5 volt. The only thing I haven't found on this is the 1.8 volt. But we know it must be present because it's working, yeah. This is 3, no, this is 12. So the 3.3 is coming in here somewhere. That's 12. I haven't even found it, but you know what? I'm not really bothered. The simple reason is because I've got everything else and because it's working, the 3.3 volts and the 1.8 must be there somewhere, yeah? Okay, so that's that one. One more we can have a look at. So this is the R9390, yeah, which you probably, I'm sure you saw before. That's a strange thing tagged on here, yeah. This is a work in progress. The initial problem with this was some components broken off here, yeah. Something that hit it. You can see where there's a corner missing out of this coil, and hit here. There was 2 components missing, and one was a transistor, and one, I'm pretty sure, is one of these logical AND gates. So I've kind of cobbled this, yeah. I've got a transistor on here at the moment, on some bits of wire, and I've effectively bridged out the logical AND gate and forced it to produce a voltage output. And now this one does actually power up. Previously it didn't power up, yeah. So on this one I can just show you. Again, we'll switch it on, we'll power it up. It doesn't detect, by the way. Powers on but doesn't detect. We can have a look on the V-core, and we do have V-core 1 volt, yeah. And we can have a look on here, which is probably VRAM 1.5, yeah. No, it's just not detected, yeah. This is probably the memory controller. Let's go back to V-core. Just now it's on, yeah. It's now dropped to 0.9 volts. So after it didn't detect, that dropped to 0.9. So that's good behaviour. Like I've just shown you, we could go around this board, and this is getting warm, not hot, but obviously with V-core and VRAM there, it does get warm. Yeah, we could go and read all the other voltages, but again, we don't really need to. This tells us if we've got V-core and we've got VRAM, we must have everything else. Yeah, and there probably isn't any need to do that. Okay, so that's all the boards we can measure voltages on. I suggest you start with V-core and VRAM like I'm doing, because it's easy to find the big buck regulators, and then work your way backwards. If they're not there, start working way backwards. Try to find PEX, try to find 1.8, and again, if they're not there, work your way back, yeah. If V-core and VRAM are missing and you find PEX, look at the enable, you know, the power good to enable. If 1.8 is there but PEX is missing, again from the 1.8 power good to the enable of the PEX, yeah. The most common reason for a regulator not to give an output is it hasn't got an enable, yeah. Other than that, yes, it could be a faulty chip. It can't have a short circuit on the output because you've already checked that, yeah, you've done the resistance checks. So if one isn't working, the most likely reason is the enable signal is missing, and you may find yourself, as I'm doing, tracing around this area, the logic area, to try and work out. The other cards I've got, I can't power them up and test the voltages, and I'm just going to explain why. This is the R9390, and we know this has short circuits, yeah, so there's no point trying to power this card up. We also know it's got blown fuses as well, by the way, so we know we'll have no voltage at all because the fuses are blown. But if you've got a board with shorts on and you know it's got shorts, then there's absolutely no point whatsoever in putting power on the board, yeah. And there's no point in putting it in the oven either, by the way. The other one, this is the GTX 770. The reason I can't power this up is because there's missing components. We know there's a missing MOSFET here, and we know there's some missing capacitors, which are somehow related to this area of the circuit. In particular, with the missing MOSFET, do not try to power this board up. The reason being, this could be a low side MOSFET, yeah, which is from the junction of the MOSFETs to ground, or it could be a high side, yeah. If you've got missing low side MOSFETs, and especially missing controller chip, or you've taken it off, don't try and power the board up. What's likely to happen is the gates of these MOSFETs now are not connected to anything, or not connected properly. And when you put power on, the MOSFET can actually turn on just because the gate's floating. It'll turn on and send the 12 volts directly to the GPU. So boards like this, you don't power them up, yeah. The one other, I said I can't. Actually, I can power this one. This is our old board. Let's just have a quick look to see what voltages we find on this one. I've never actually looked at the voltage on a graphics card of this sort of age, to be quite honest. So this is a bit of a new thing for me. This card's working. Power on. It does detect, yeah. Let's see what voltage we've got on it out of interest. So let's find the ground first. It detected, yeah. I'll put this on here just to try and keep it a bit cool. So there's a voltage, there's some coils, inductor coils. Let's have a look. 12 volts on that one. The coil here, it's not getting too warm. The coil here I can't easily get to the other, to it to go from the other side, yeah. Let's have a look at this one. What's on this? The big pins here. That's a 1.1 supply. Okay. Almost certainly for the V core. While we're at it, on the back of here, there's some voltage regulators here and here, yeah. Let's just see what's on these. Nothing on that pin. That's a 1.8 volt regulator. What's coming in? 5 or 3.3? 3.3, yeah. This one is a 5 volt regulator. Probably got 12 coming in, yeah. Let's have a look on the other side of the board. So I found what looks like V core. Put my little bit of stuff on there, keep it a bit cool. So this is V core. V RAM, maybe this one at this end, yeah. I don't see any more coils on this. Let's have a look. 2 volts. I'm pretty sure that's V RAM. Coming in is running from the 3.3 volt supply. Okay, so that's an old one. But it's similar. We found the V core, we found the V RAM. I'm assuming this has got PEX somewhere. I'm sure it must have PEX, otherwise it couldn't talk to the PCIe interface. Yeah, but because I know it's working, but also because I know I've got V core and V RAM, it must have PEX. Yeah. Okay, so that's that one. Now we've made some voltage checks, we've managed to diagnose where the problems are on some of our cards. All these graphics cards, by the way, or many of them, have actually been previously looked at by myself, and I will link from this video to the various videos for each card. So if you want to look in more detail how I diagnose the problems with voltages and resistances on these cards, then you'll be able to do so. You'll have the link from this video. But now let's carry on. So there's only one card left that we haven't really diagnosed a problem with, and that's this one, yeah. And the problem with this one is that all the voltages appear to be present, but the card isn't being detected by the PC. And I will say, by the way, I don't know what's wrong with this card. I haven't gone any further than I went so far with the business of the problem in the logic here, which I've kind of botched to make it work. At least I've got voltages now. So that's going to be the next section, a new chapter in this. We'll call it the lights are on but no one's home. Yeah, everything's present, all the voltages are there, but it doesn't work. A GPU basically is a processor, like a microprocessor, like the CPU in your computer, yeah? And a processor needs certain things to be there and to happen for it to work, to operate. So let's have a quick look at our GPU, okay? The first thing it needs to work is power. Yeah? And we know it's got power. Yeah? We also know it has power to the RAM. Yeah, it's got RAM and the RAM's got power. Yeah, so it has RAM. And the RAM's connecting to the GPU. Very crappy little bit of a diagram that. And that's got power. Yeah. Okay. It also needs to execute some code when it first starts up. Yeah, and the code it executes can't be in the RAM because the RAM's volatile. When the power's off, all the contents of the RAM disappear. Yeah, so it needs some code to execute to start off with. Yeah, and that code is in the BIOS. Yeah, okay, and the BIOS itself needs power. Okay, well, the other thing a processor needs to operate is a clock. a crystal, a frequency clock. You know, like you have your however many gigahertz processors, you know, your CPU on your motherboard, yeah, and it needs to have a clock, yeah. So it needs a system clock, okay, coming in. The last thing the processor needs to work, basically, is a reset signal. Reset, yeah. So basically, when you first switch on, the reset is asserted. It's in a reset state. Yeah. Usually it's low, which means we put a solid line over the word reset. In electronic terminology, that means active low. And the computer will keep the reset low until the power's on and everything's ready to go. Yeah. Okay. So that's what it actually needs to boot up. Yeah. And these are some of the things we can check, yeah. The GPU is also connected, the interface, if you like, 16 lanes, yeah, 16 times PCIe lanes, yeah, to your PCIe connector, yeah, socket, yeah, okay. The voltages we know where they come from. We know the BIOS. 1.8 volts, yeah, and that's one of the voltages that we've checked as present, yeah, and we know it's got power, you know, 0.8 volts the core. The PEX is effectively this interface, we know that's working, yeah. So where does the clock come from? The clock comes from a crystal, and that's a component actually on the board itself, yeah. There'll be an oscillator crystal on the board itself. That's the clock. The reset, as you might expect, comes from the PCIe, yeah. So this effectively is the reset signal to the GPU, yeah. When you first take the reset off the GPU, so it's no longer reset, yeah, the GPU will start running. But your computer doesn't know that that PCIe card is a GPU. It knows there's a PCIe card inserted, and that's because there are pins on here which are hot plug pins. So effectively, when you plug this into the slot, it connects some of the pins on the slot together. Yeah, they're over here. It connects some of the pins in the slot together and effectively shorts the pins together, and that's how the motherboard knows there's something in this slot. Yeah. So while the motherboard's booting up and the BIOS on the motherboard's controlling the the program that the CPU is running, at some point during that BIOS sequence, it will ask the card, "What are you?" Yeah. And the way it does that is with a couple of signals down on here, called SM clock and SM data. Yeah. And possibly also through the first of the PCIe lanes. So that's how it asks the GPU, or rather asks this PCI card, "What are you? What are you?" Now, the GPU doesn't have any memory built in. It can't store any information. The RAM is volatile. So it kind of has amnesia, and it doesn't actually know what it is. So it has to ask, "What am I?" And the way it does that is to query the BIOS, yeah. So it goes to the BIOS and it says, "What am I?" And the BIOS says, "Oh, yeah, you're a GPU." So this replies back to the motherboard, the CPU. It says, "Oh, I'm a GPU and these are my parameters. Yeah, this is what I am. Blah de blah de blah." And that information is coming back down the SM data, SM bars, or the first lane of the PCIe. Okay, and if your motherboard is happy with the response it saw, it then takes control back into its own BIOS, and it knows that graphics card's there. So that's what should happen, yeah? Right, what we need to now understand is, why might it not happen? Okay. The first reason it might not happen is because the reset never clears. So the signal coming from here to the GPU never takes the reset off, so it's just reset all the time. It can't do anything, yeah? Second reason it might not work is because this SM data, SM bus pins on the PCIe, or the first PCIe lane, there's some problem with it. So effectively the query, "What are you?" never gets to the GPU. Okay. Third reason it might not work is the GPU can't read the BIOS for some reason. Maybe the BIOS is corrupted. There's a problem with the BIOS. So when it says, "What am I?" it says, "I don't know," and that can stop it from working. Fourth one is if there isn't any clock. So if there's no clock running, it can't do anything. It can't operate without a clock. Yeah, so it can't even hear this request. You know, it's like it's often the cloud cuckoo land. Yeah, can't do anything. The last reason why it might not work is because the GPU itself is faulty. It's a faulty, there's damage, internal damage, and it just can't work. Yeah, so those are really the reasons. So for us to diagnose this problem that we have, we need to look at how all these things work and then see if we can look on our GPU to, for evidence. Is this happening? Is this not happening? Okay, so let's have a close look again now at the graphics card. The only places we can easily get to the signals going in and out of the GPU are on the PCIe interface, okay, the connection to the BIOS, which is normally an 8-pin chip and normally quite close to the GPU. In this case it's this one. BIOS chips almost always start with like number 25 or 26, yeah, 25Q, 25L, 25D, that sort of thing, yeah, and then some other numbers which generally specify the capacity. I've looked this one up. This is the BIOS chip, and possibly we can get to some of the connections that are going to the DVI connector or the HDMI connectors, yeah, but we're probably only interested in these if we've got a board that actually detects but doesn't give a picture, or more specifically detects, and if you use as a secondary card, which you can do in Windows, so it's a GPU but a secondary card, it outputs the picture fine through the onboard video connector, but if you try to connect to its own, it doesn't. Yeah, that's possible. That's a different sort of fault though than what we're looking at. It's not what we're really interested in today. Topic for another video. Yeah, so let's look at the signals we were talking about. So the first ones are on this part of the PCIe connector, yeah, and on this side we know the first three were 12 volt. We've looked at them many times, yeah. Number 5 and 6 are the SM buzz and the SM data, yeah. Let me just find a pointer or something. So that's these two, yeah. We can see on this they disappeared out a couple of wires here into the board, yeah. And if you look on the other side to see where those are, just turn this over and adjust the focus a little bit. See if we get into focus. Only just about, because it's quite a big card. But basically, if you can see it, it's not focused very well, unfortunately. They come through here, the two small ones by the end of my pen, and they go to pads here. Yeah, some pads here. So we can check the signals where we can effectively use our resistance meter and find out where they go to, and we can check those signals there, yeah. But the main thing I'm interested in really is if there are any shorts on those, because if any shorts to ground, this is not going to detect. Okay, so let's get the meter and let's have a look. Let's measure a few more resistances. Okay, we have our test meter. I'm on continuity mode but not diode mode, yeah. Let's just have a look to see then if we have any shorts to ground from these two. So it's pins 5 and 6. No. And no. So there's no shorts there, yeah? Okay. The next signal we're interested in on the PCIe is the reset, yeah? The reset. SMRST, I believe the signal's actually called, which is like platform reset, yeah? And again, if I can just adjust the focus a little bit, we can probably see it. Sorry about the fact I can't focus around the back of this board, but the signal is on the end one here, pin 11, yeah, and you can see the signal trace comes up here and it goes to this 5-pin device. This is quite common to see something like this. This is a logical AND gate, so basically it has power and ground, normally runs from 1.8 or 3.3 volts. It has 2 inputs and 1 output. One of the inputs comes from this reset. The other input almost certainly comes from the power sequencing logic that says the power sequencing is complete. So it says, okay, I've got complete power sequencing, reset is removed, they both go high and the output goes high, and it takes the reset off the GPU. So again, we need to check on this pin to see if we have a short to ground, and we don't have. Yeah, I mean, we can come back later and we can check with a meter or an oscilloscope. If we think we've got problems, we can come back and look at this area of the circuit. Yeah, this 5-pin device. Okay. The next thing we need to look at are the PCIe lanes. Now, if you look at the board, you'll see that you've got what like wires going up here, but they're actually pairs of wires. Focus that in a little bit there. Okay. Yeah. So each one of these pairs of wires is a PCIe lane. Yeah, the narrow ones, and you can see if you look where they all go off here and they'll all go up underneath the GPU. Yeah, so this effectively is the interface between the GPU and here. Now what we should do now is check for shorts on any of these, and they should all also read the same. It's probably easiest to do this on diode mode. So right, I put my meter into diode mode. Okay, let's have a look to see if we have. Effectively, I'm trying to find there's any that look different from the rest. While we're at it, seems on diode mode, let's have a quick look again at the SM bus. Nothing, nothing. Okay, let's go to these. 0.76. Yeah. 0.76. And we can keep working away along each of these pairs. Okay? What we're looking for is one that reads different from all the others, yeah, or more than one. If we find ones that are short or reading completely different, then almost certainly the PEX part of the GPU is damaged, and really we'd have to change the GPU. Yeah, if you find any open circuits, you might just find the case that the GPU effectively needs reballing, yeah, some sort of problem like that. So I'm just going to go along this board now myself, and I'm going to check all of those just to see if they're okay. Okay, they all tested the same, all read 0.76. So let's now have a look at the other side of the board. I'll probably do this with the overhead camera because I'm not focusing well with the microscope. So on the other side of the board, we'll find a similar thing, yeah? But in this case, there are little capacitors, yeah? And if you count them, you'll find there are 16 pairs, yeah? And on this side of the board, we can do the same sort of check, but we need to check from effectively the other end of the capacitor, the end furthest away from the PCI. So if you go into here, you'll see there's nothing, yeah? If you go onto here, and it's reading a different lower one. They all should read the same, but you may almost certainly find that they read different, yeah, from the other side. So again, you need to go across all of these capacitors and check. It's also worth a good visual look. If any of these are broken, cracked, chipped, then that is a good reason why this board won't detect and you need to replace them. Once again, I'm just going to check all these myself. And once again, they all checked okay, so that's good, yeah. So I can't see any problem with the interface into the GPU, at least not from these sort of checks, yeah. So another thing we ought to check, and we do need to check, is if any of these capacitors are short, yeah. If any of these are short circuit, that would stop it from detecting almost certainly. Easiest way is just to go to this end and just effectively just move across, and they should all read open circuits. I'm on bleeper mode, so if there's any shorts I should get a bleep off mine. But that will depend on your meter, yeah. So we can just go across all of these, just looking to see if we have any short circuits. Yeah, these all look okay, just the last few. So we can say on this board again there's no problem there, yeah, they're okay. So the next thing we can just check really is to put this on and power this up, and let's see if it is communicating with the BIOS, yeah. To do that, we really need to find the datasheet for the BIOS. Now, I couldn't actually find the correct datasheet for this, but most of these 8-pin SPI BIOSes, as they're called, have got the same pin out. So I'm just going to go from another one and hope that it's the same on my board. Let's just go to the computer desktop and let's have a quick look. Okay, so here we have a typical pin out. Yeah, so basically the BIOS chip has a clock input. Yeah, it has a chip select, and it has a data out and a data in. That's what we're really interested in. Yeah, it has power, obviously, the 1.8 and ground. This chip select has a slash against it. You see that slash? That's the same as putting a line above it in electronic terminology. That means it's active low. So when this is low, 0 volts, basically it accesses the chip, it selects it, and now you can read data in and out. Yeah, this one here, slash WP, this is like read write, I would say. Again, it's active low. Yeah, but what we're really interested in probably is if the GPU is selecting the BIOS. So if we have a look on pin 1 and see what happens when we boot the card up, we should see this switching to low. Yeah, and we can also have a look at the data. So on pins 2 and 5, it looks like the data in and data out, and pin 1 is a chip select. As I said, I don't know exactly that matches our BIOS, but I think there's a very good chance that it will. The last thing we can just look for, one moment. Okay, the last thing we can just look for, I mentioned, is it needs a clock. Yeah, the clock is a crystal on the board, and normally it's a silvery looking thing. In this one, that's the clock. Yeah, sometimes it's oval, a bit bigger. So can I find another one? So find another clock. This has the same sort of silvery thing here. Yeah, that's your clock. And it may look more like an oval can, about twice as long as that. Depends on the graphics card. Okay, so let's get this powered up. This is where we need the oscilloscope, and let's see if the GPU is actually trying to access the BIOS. If it is, that means we know for certain that the reset's off, yeah, and that the motherboard is trying to talk to this, and this has received the request to identify itself, and it's now saying to the BIOS, yeah, but what am I? Okay, let's see if that happens. I thought I'd just show you on the working board first. This is a GT 740, this one, yeah. But I know it's a working board, and we'll just go to the end here. I'm not using the 750 because it's just all awkward to hold it upside down with a fan. Yeah, it's a bit easier. So I'm on pin 1. You can see the oscilloscope. So let me just start it up and you'll see what happens. I'm on the chip select pin 1. So wait for it to just start up, and we should see the GPU there. You see it? Yeah, that's the GPU talking to the BIOS. Okay, and that's what we'd expect to happen. Now let's have a look at our card, our faulty one, and see what that does. Okay, we're back to our R9 390, and let's just try the same thing on this one. So we'll switch the power on. Yeah. Let's have a look to see if this one tries to detect the BIOS. So far nothing's happening. Yeah. Okay. Hopefully it will bleep. It can take a little while, this board, sometimes before it actually does bleep. Yeah. There you go. But you see, nothing's happening. Yeah, it's not trying to read the BIOS. So in the case of this one, we know either the GPU isn't getting the request to announce what it is, or something like that. Yeah, we can check just out of interest. If I can get to the back of this board easily with these cables. Let me just arrange this. I'm now looking at the logical AND gate here down by the reset signal. Yeah, and I'm actually on the output of the AND gate. So there's two inputs. One comes from reset, one will probably come from some sort of power grid, and what I'm interested to know is the output, which goes to the GPU, is that effectively going high. Yeah, so let's have a look. I'm on the pin now. Let's power this up, and there, it's gone high. Yeah, so the GPU isn't stuck in reset. Okay, but it's not reading the BIOS. The next thing we can try, just while we're on this, is the other thing I mentioned earlier in the video, is the crystal. Yeah, the oscillator. So Let's have a look to see if the oscillator's running. About the last thing we can check then is if the crystal oscillator is running, as I say. Yeah, so I'm actually on my analog scope now. I often find it better than the digital scope for these sort of signals. So I'm on the oscillator, and there, as you can clearly see, it is in fact running. Yeah. So it looks like this card probably has a faulty GPU. I mean, it's got all the power rails. All the power rails are there. The reset goes off, so it's not reset, but it never accesses the BIOS. The oscillator's running. I can investigate this a bit further. I've already made one video on this card, and just have a look to see if I can see effectively the request coming in. Yeah, so it's effectively, there's going to be some circuitry between here and the GPU where effectively like it asks you what it is, and obviously if it never gets a request, it will never read the BIOS. But that's something for another video. This one's long enough, and I believe I've now shown you all the techniques you can use really to diagnose the faults on GPUs. So that's the last of our graphics cards then. This one appears to have a faulty GPU. All the voltages are there, but it never requests from the BIOS, you know, any data. So that either means we know the crystal's running. I will spend a little bit more time looking at this. There might be some problem with the interface from the PCIe to the GPU, so it never gets the request to declare what it is, yeah, to identify itself. So I'll put that in another video. This one's more than long enough now. I will say this is the most ambitious video I've ever done for YouTube. I've divided it all into chapters to make it easier for you to sort of digest this in chunks. I hope some of you will watch this all the way through. Those of you who watch it all, maybe in a few sessions, you're the guys who are going to learn how to do this, yeah? The ones who just skip around it, well, if you haven't got the time and the energy and the dedication to learn from these sort of videos, then, in all honesty, you haven't got the time and energy and dedication to sit down and start diagnosing graphics cards. Okay guys, look forward to hearing in the comments from you below. Please let me know what you think. As I say, I will link to all the other videos that are related to these graphics cards we've seen, and in future if I get any more that demonstrate certain points, I will also link them from this video. Okay guys, I hope you enjoyed that. See you all soon on another video, and ciao for now.